Let us discuss about different types of signals. So in the category of the classifying the different types of signals, we come across with the energy signals, power signals, and mostly about the periodic signals, non-periodic signals, causal signals. Okay, there are a lot of signals we are going to discuss about. So let us first see about energy signal. So for any signal x of t or x of n, we define the energy of that signal as E equal to integral minus infinity to infinity x of t mod square dt. So this gives the energy of a signal x of t. Okay, and for any signal, if there is an existence of such a measurable quantity which is energy, it must be a finite value. That is, for a signal x of t, E must be less than infinity, that is, E is finite. The same for the discrete time case. So E is given as not integral. So this is summation n equal to minus infinity to infinity mod x of n square. Okay, so if E value is finite or less than infinity, there is an existence of a measurable quantity, that is energy E. Okay, so in this case we can say it another wise as, for any signal x of t, as mod t tends to infinity, okay, the strength or amplitude of x of t, simply mod x of t, should tends to 0. That is, the signal should converge in both negative time and positive time. Okay, simply can say if the signal is like this, there is an existence of E. Okay, if the signal is like this, that is, it's not converging, it's moving in this direction, in the positive t and the negative t. Okay, and there is no energy. Why? Because the integral will not converge. So as the amplitude tends, as the t in either in the positive direction, positive t or negative t, as you move on, the amplitude should go for 0 of that signal. Then there is an existence of energy. Okay, right. So for the power signals, okay, let us see about power signals. So for some signals, okay, let you take as a periodic signals. So in the periodic signals, the signals, I'm taking this sine wave. So as for the positive time and the negative time, the signal move on to this infinities. Okay, not at any point it's going to 0. Okay, it's not converging, that is, integral will not converge. In such cases, or for such signals, you cannot find out the the energy value. Why? Because the energy will be infinite. So there should be a meaningful measure. Okay, there should be a meaningful measure for this signal x of t. So for that one, we go for a measurable quantity which is power. So here it is an time average of the energy. Okay, know that for such signals energy is infinity, right? So here we take the time average of the energy, which is given as limit t tends to infinity 1 by t integral over minus t by 2 to t by 2. This is over a period x of t square dt. So you can observe this one is the energy, okay, energy over a period, okay, energy over a period, and we are dividing it with or multiplying it with 1 by t, and considering that t tends to infinity. Okay, so we consider here the time average of the energy. So this was the continuous time case, and for the discrete case the power is given as limit n tends to infinity 1 by 2n plus 1, that is n equal to minus n to n, or the summation x of n square. Okay, so here t is the period of that signal, and you can say here every periodic signal is power signal, but not every power signal is periodic. Okay, you have to remember this one. Every periodic signal is a power signal, okay, but not every power signal is a periodic. So while discussing about different problems, we can come across as such differences. Okay, so calculating the power of a periodic signal, okay, so you can observe these differences, right? So here also the power should be less than infinity, then only the power exists. So there is a signal x of t, there may be existence of E, there may be an existence of power, or neither power or nor energy, okay, neither P or E. So the x of t may be energy signal or power signal, that is maybe power signal, it may be neither energy nor power. Or power signal. So there are different signals, maybe either energy, either power, and neither energy nor the power signals. Okay, let us see some examples regarding with this. So let me calculate the you calculate the energy. So first x of t is e power minus 10 t into u of t. So you know that e power minus 10 t is an exponentially decaying signal and u of t is a step signal. Okay, you multiply these two signals, e power minus 10 t and u of t. The signal is e power minus 10 t pattern is followed from 0 to infinity, like this one. So by observing the signal x of t, you can say that as t tends to infinity, the amplitude is going to 0. You can take the plus t and minus t, amplitude is going to 0. So you can directly say it is an energy signal. So let us calculate the energy. So E equal to, you know the equation, let us integrate over a period of minus infinity to infinity. Okay, so x of t mod square dt, and this is existing in the range of 0 to some infinity. Okay, so you can take it as let me rewrite this as equal to limit t tends to infinity, okay, 0 to t, and e power minus 10t square dt, and this is limit t tends to infinity 0 to t e power minus 20t, okay, e power minus 20t, 10 into 2, 20t dt, okay, and this will be equal to e power minus 20t by minus 20. You substitute 0 to infinity. So what you will get? So you will get the value that is minus 1 by 20. So e power minus infinity, okay, this will be equal to 0. So e power minus infinity and e power 0. So minus 1 by 20. So 1 by e power infinity minus 1. So 1 by e power infinity. So denominator is infinity, the maximum value. So this value will goes to 0. Okay. So 0 minus 1 minus 1 minus 1 into minus 1 by 20. The value is 1 by 20. So the E is 1 by 20. So it's an energy signal with an energy 1 by 20. Okay. Same, let us see an complex signal, an example with x of t equal to e power j 2t plus pi by 4. The same, let me write the expression limit t tends to infinity integral over minus t to t, say e power j 2t plus pi by 4 whole square dt. So what is the strength of it? The strength of it is simply the 1. Okay, it's an e power j 2t plus pi by 4. Okay, it's a complex exponential. So if you expand it 1, you observe the strength will be 1. Okay, so the strength is 1, and as you substitute the limits, that is minus infinity to infinity, the value will be, that is limit t tends to infinity, this will be equal to infinity. So you can say that E is infinity, so not an energy signal, but because it's a periodic signal, e power j omega t or else e power jt, it's a periodic signal. So there is no need to go for the further calculations to check whether it's a periodic or not. Okay, so you can check it by observing or by applying the fundamental equation, that is x of t equal to x of t plus t. Okay, by using this expression you can check that e power jt whether it is a periodic or not. Okay, so it's not an energy signal because E is infinity. So let us check about what is power. Okay, so if you substitute the expression limit t tends to infinity 1 by 2t, okay, 1 by 2t again minus t by 2 to t by 2, sorry, not, you can write 2t or t like this. Sorry, t by 2. Let me write the previous expression, that is for the power calculation, P equal to 1 by t minus t by 2 to t by 2 x of t squared dt, and you know this one. Okay, let me rewrite this. T tends to infinity, 1 by 2t minus t to t, again x of t square dt. So you know this one. Okay, you know this equation. This is 2t. So 1 by 2t into 2t. Sorry. And this we got it from this point. So 1. So both, sorry, this is not 2t. So we got that power is 1. So you can say this is less than infinity, and it's a power signal, and it's an periodic signal also. Okay, it's a power signal and periodic signal. Right. So now let us take another example. X of n equal to, in the discrete case, 1/3 power n un. Okay, so a power n u of n. So a is less than 1. So a value is less than 1. So you can say the value will decrease as n tends to infinity. The same, mod n tends to infinity. So the amplitude goes to 0. Then it's energy signal. So let us check that. So E equal to limit n tends to infinity, summation n equal to minus n to n x of n mod square. Okay. So this expression is in the range of 0 to infinity. Why? Because of u of n. Okay, so if you plot this signal, x of n equal to 0, 1 by 3. Okay, n equal to 1, sorry, if n equal to 0, it's 1. So n equal to 1, it's 1 by 3, 1 by 9. So like this. So the existing from 0 to, the summation is n equal to 0 to infinity, or else let me take it as an n equal to n, as limit n tends to infinity, right? Third, so it was 1/3 whole square. So this is an infinite sum. So that is summation n equal to 0 to infinity 1 by 9. Okay, and this will be like 1 plus, like this. You have to sum it everything. Okay, 1/3 power, I missed it, 1 by 9, sorry, 1 plus 1 by 9 plus square, like this. Right. So let us sum all these things. The expression, the shortcut is 1 by 1 minus r. So that is r is 1 by 9. So simply can say for summation n equal to 0 to infinity a power n a by 1 minus r, okay, where r is the common ratio and a is the first term. So 1 by 1 minus 1 by 9, so you will get 9 by 8. So this is the energy and it's finite, okay. So 1/3 power n u of n is energy signal, okay. So like this you can check about whether this given signal is energy signal or power signal, okay, right.